Hello, we're at the CDG&OXALOR plant in the outskirts of Luzay in central France, close to Poitiers. I will show you around this ultra-modern facility, currently unique in the world. Here we treat approximately 60,000 tons of household waste annually from the town of Niort. That comes from about 180-200,000 citizens from the department de Sèvres. The plant here has a built-up area of 3,600 square meters and sits on a plot of 14,000 square meters. We have local water supply and ventilation system with 75,000 cubic meters capacity. This is the control station, and now we will start up the installation. Now the startup sequence begins. Machines turn on one after the other, commencing from up there through the entire sorting workshop. The entire control system of the plant is connected to this computer. Now we shall turn on the sorting machines. We already have 27 tons of waste loaded into the line, and we will see the whole process. I've put the system on full auto, and with a single press of a button the machines will be switched on one after the other. When I see that the last machine is turning, we will let the waste go through the cascade. This is the mixer and that is the new one. And with this we can control everything remotely through the Wi-Fi network. We can start up and stop machines while walking around the plant. So the waste is unloaded from the trucks onto this conveyor behind me. From here on it goes up on these belts, where it is weighed on the move and the corresponding quantity of our reagent CDG&OXALOR is measured and fed into the flow. Then it all goes into the mixer for 40 minutes. For 40 minutes we mix up the waste and initiate the exothermal reaction, which is the basis of the treatment process. Unloading the mixer on this conveyor belt, the waste goes into the thermal absorber down there behind me. There it is sterilized over 90 minutes. Here we have the vapor washer, and behind it is a thermal absorber which holds 20 tons of waste and allows us to adjust the speed of the entire processing line. Inside, the waste is rendered hygienic and the temperature is 80-90 degrees centigrade, and that takes about 90 minutes. So 2.5 hours after entering the line, these machines have disinfected the whole mass. Next, we carry on the separation of all useful contents, which are divided in two main flows: organics in the refining workshop and the non-organics by the optic sorting machines, which are nearby. Let's move on. So, behind me you see the silos for our reagent CDG&OXALOR, which is based on calcium oxide, and the first unit that splits the flow into fractions. From this side the organics and the non-organics from the other side. Here is the refining workshop. This means for purification of the organic fraction, so that we obtain one finished agricultural product called oxyom. We begin by sorting out the ferrous metals from the flow. Here we have tin cans, coins, a bunch of different waste. Then we have the non-ferrous metals. Small bottle caps, aluminum foil, that's aluminum too. They come from a separator with Foucault currents. This is the first flip-flop vibrating screen. It sorts out all foils and small pieces of plastic bags, so that we obtain the product in the container outside behind me. And so the product is loaded into such containers, and they are stocked here on the apron prior shipping to the farmers. This section of the plant carries out the refining, where, as I told you, we get rid of the ferrous and non-ferrous metals, the small plastic pieces, generally said all impurities, in order to obtain one finished product called oxyom, which is sold to farmers here in France. So we've seen the organic part, and now we'll look into the non-organics. Upon exiting the trommel, we sort out all useful waste. These are plastic foils, bottles, PET, high-density polyethylene and so on. The first device after the trommel is an airflow sorting machine which sucks in all foils and plastic bags. They can be seen down below. Next, the flow goes up to the so-called overband, a magnetic separator for the ferrous metals. After getting rid of them, the waste goes into the so-called optic sorting machine, which splits the flow in two. The first part contains all sorts of plastic which follow their own way down the cascade to the cages down below, where they are sorted by type. The other part passes through Foucault current separator for the non-ferrous metals, here underneath, and the rest is alternative fuel which goes there behind. This way we exhaust all opportunities for useful utilization of the waste materials. All that remains is inert and disinfected materials, which are turned into alternative fuel by the machine behind me, right there. This is the last unit of the plant. All waste that ends up here is chopped to a 1-inch fraction and is headed to the local cement factory, where it is used as alternative fuel. The heating value of this product is 4000 kilocalories per kilogram. We are standing in front of the useful waste. In this bin we have various tissues, textiles, cardboard, etc. In this cage we have PVC, which is problematic material for the cement factory because it releases chlorine when burnt. Here we have the polypropylene. Everything made of PP goes into this cage. Behind we have the cages for PET, high and low density polyethylene. In the last bin go all the non-ferrous metals, predominantly aluminum. When the cages are full, the content is fed into the baling press, and after that every material follows its own path of conventional utilization, as practiced everywhere.